Today we will be discussing sinter versus pellet, two key iron bearing material used in blast furnace. We will explore their differences in production, composition and performance to understand their overall impact on steel manufacturing. Now, as far the process part is concerned, as we all know how these materials are made. Sinter is produced by fusing a mixture of iron ore fines, fluxes, coke breeze, and various recycled material on traveling crate. This process results in a porous clinker-like material. Because it has limitations regarding transport, sinter is typically produced right next to the blast furnace where it will be used. In contrast, pellets are created from the iron ore concentrate, which are formed into balls with binders and then fired to create hard durable spheres. This durability allows them to transported over long distances, making them an internationally traded commodity. Now, let's look at their chemical makeup. A major difference is the iron content. Pellets have a significantly higher iron content, typically between 62 to 66% compared to sinter 55 to 58%. This is a direct result of the beneficiation process that pellet undergo. This also affect the gang content, which reflect to which refer to impurities like silica and alumina. Now, pellets contain lower level of these impurities, which leads to lower slag rate and reduced coke consumption in the blast furnace. Now, coming to the our chemical composition, continuing with the chemical composition, another key factor is basicity, which is the ratio of calcium oxide to silicon dioxide. So, sinter is produced with a higher basicity, usually 1.7 or greater, to ensure the strength. However, this high basicity means higher flux requirement, and which in turn lead to higher slag rate. So pellet on the other hand typically have a lower basicity in the range of zero point 0.8 and that is a one advantage we can say as far the slag volume is concerned. Uh, Now these physical and chemical differences dictate how each material is used and transported. Sinter, due to its relatively lower mechanical strength, is used close to blast furnace where it is made. Pellet, however, are much stronger and more durable, which means and makes them also for suitable for global transportation, and they are generally categorized based on their end use, either as a blast furnace pellet or DRI pellets. Now, coming to the performance in blast furnace part is concerned, we can say that we are going to look into how these characteristics affect the performance in the blast furnace. So, higher iron content in pellet directly enhance furnace productivity and helps reduce transportation cost. The lower gang content in pellet is a significant advantage and it reduces slag rate that we have already discussed in the preceding slide, and which means that less coke is needed as slag volume also comes down for melting this slag, and there is a less slag to dispose of, as we have already mentioned. And conversely, the high basicity of the sinter increases the slag volume and overall operating cost. This also is being discussed earlier. Now let's compare the reduction efficiency, which is how well they utilize the reducing gases, carbon monoxide for sinter, which require less CO2, and we can see an efficiency of around 85%. For pellet, the process require more CO to be injected using the provided figure. This result in slightly lower efficiency of 83.3%. So this is because more CO is required overall and more of it remain unconverted in the top gas. In summary, while pellet have many advantages, sinter demonstrate a slightly higher CO gas utilization efficiency. As far the process overview is concerned, Sintering is the agglomeration of iron ores with fluxes and coke fines in dedicated sinter plant. The main step including granulation, sintering on a strand and crushing. The output is sinter, which is characterized by higher basicity. Pelletizing involves preparing green pellet from a beneficiated iron ore fines, which are then hardened through a thermal process called induration. Additive like bentonite are used as a binder and result in uniform size pellet with a high iron content and consistent quality. Now, coming to our next slide, let's look at the implication of these properties. From a chemical standpoint, the higher iron content in the pellet boosts productivity, while their lower gangue content reduces slag formation and energy consumption. From a physical standpoint, and uniform size, superior strength of pellet are key advantages. So these enhances the permeability of the material in the furnace also, and which allow for a better gas flow and also reduces the creation of fine particle during handling and charging. So coming to our metallurgically pellets, which are also show superior performance, they exhibit a better reducibility and have a higher resistance to breaking down under reducing condition inside the blast furnace. This leads to a more efficient reaction between gas and solid material in the furnace. However, improving overall efficiency is getting improved. Coming to the performance matrix, where the performance matrix is concerned, palette, when we look at a key performance matrix, the advantages of the palette become very clear, and as we have come across, either we talk about lesser slag formation, good strength. So in all terms, and it helps in achieving a higher productivity and high iron content and a better permeability provided by the pellet to improve the furnace output. Sinter is limited here as by higher gangue content, which increases this our slag volume. uh, uh, Regarding coke consumption, also pellet also have a distinct advantages because they form less slag, as we have seen all this, and they can reduce coke consumption by up to even 5 to 10%. 5 to 10% coke can be consumed lesser, and this is the basically advantages disadvantages of the emission system in sintering process and pelletizing process. So we can see that pelletizing process is going to have a more reward as far the best gas flow is concerned, the dust outgoing gases from the system, SOx and NOx is concerned. So everywhere this pelletizing is having a more advantage compared to sinter plant. So this already is being discussed, the environmental impact, and the pelletizing process generally has a smaller environmental. So we can say that based on the discussion, the pelletizing process generally has a smaller environmental footprint, resulting in a lower emission of pollutant like CO2, NOx, and SOx, and dust, particularly when using magnetite ore. Especially in contrast, sinter plant are associated with a higher emission, including NOx, SOx, and particulate matter from their operation. And this is also reflected in a data comparing air emission from the plant in all this slide is shown. So, coming to the our economic consideration, from a economic perspective, there is a trade-off. Pellet typically have a higher initial production cost due to the energy intensive beneficiation and induration process. However, these costs are often offset by long-term saving achieved through the improved furnace efficiency and reduced coke consumption. Sinter can have a more cost effectiveness for integrated steel plant that have their own in-house production facility, allowing them to utilize internal resources, and recycled material. And now our key finding are like these, that in summary, the choice between the sinter and pellet as the main component of the blast furnace body has a wide ranging impact. It affect not only the productivity and environmental performance, but also critical metrics like coke and slag rate, and ultimately the entire steel plant.